When working in predicate logic, one of the things we would need to understand is the notion of binding a variable. So let's look at a proposition function p of x. Now here I have a variable x. We are going to define a variable to be either bound or free. So we say a variable is bound when either we assign a value to it or we quantify over that variable either existential quantifier or universal quantifier. Otherwise, we say that x is a free variable. When we have more than one variable in a proposition function, the order of the quantifiers is very important. Unless all the quantifiers happens to be of the same type, that is, if they are all universal or all existential, we can switch them around as we like. However, if we have a universal quantifier and an existential quantifier, then the order in which we have them is important. We cannot switch them haphazardly. All variables of propositional functions, when they are bound, it becomes a proposition. So let's say if I have p of xy, let's say it denotes x is less than y. If I say there exists x p of xy, then variable x is bound, but variable y is free. The reason we say x is bound is because this x now is bound by this existential quantifier over here. Because I have at least one free variable, this is not a proposition. If I say there exists x p of x comma 2, now this is a proposition because all the variables are bound. X is bound over here and y is assigned the value 2. I could also create another proposition that says for all x there exists y p of xy, x is bound to this, y is bound to this. Note that once we bound a variable with a quantifier, we cannot assign it a value. So for example, we can't do this. There exists x p of 3y. Because we have already quantified over x, now we can't assign it a value 3. So far, we have defined what universal and existential quantifiers are. We have defined what universe of discourse is and how we evaluate these different formulae. Now what we are going to do is we are going to play with this formula a little bit to see how they are related to each other. One particular thing we are going to look at is from the perspective of negations. So we want to show that not of for all x px is same as there exists x not of p of x. And the same way here, not of there exists x p of x is for all x not of p of x. So let's first of all see why this is the case when we have universe of discourse that is finite. So if the universe of discourse is finite, then we can write a universal quantifier as a conjunction and an existential quantifier as a disjunction. So now let's start with the universal quantifier. So I have for all x p of x, I'm taking negation of that. So I'm going to replace for all x p of x by its expansion, which is this conjunction. Then what I'm going to do is I'm going to push that not in using, you could think of this as De Morgan's law or duality law, etc. So I'm going to push this in. So every p of x1 will become not of p of x1, p of x2 will become not of p of x2, and so on. I got this. Every and will become into an or, and now I can say that this is basically same as there exists x not of p of x. And the same thing will work for the other side. If I started with there exists x p of x and negate it, I will get the same thing. I'm going to mark this slide as very important because I want you to see what's happening over here. These two rules will be very important when we start writing proofs with predicate calculus, because this is something we'll have to do every time we need to convert universal quantifiers to existential quantifiers and vice versa. Earlier we looked at proposition Lansing is a small city. We negated it to Lansing is not a small city. It's essentially we introduced the word not in the sentence to negate it. Things don't work like that once we are in predicate logic. So let's look at the statement every city in Michigan is clean. The negation of that is some cities in Michigan are not clean. It is not every city in Michigan is not clean. So essentially we can't just put the word not in the middle of a sentence to negate a statement that is in predicate logic. We have to also change how the quantifiers are working. In particular, we had to change this every to some. So this was like a for all quantifier. We had to change it to there exists quantifier in making this change. What I'm good. So here is a summary of negating quantifiers. If I had there exists x p of x and I want to negate it, this statement is true when p of x is false for every x, and it is false if there is some x for which p of x is true. If I want to negate for all x px, then this statement is true when there is at least one x for which p of x is false, and it is false when p of x is true for every x. I want to make sure that you understand this, exactly what it means, and this if there are any questions, this is something we should discuss in class or on PHSA, etc. If we have a formula that contains for all or there exists, we can do the negation of that formula using the same ideas that we did with the duality earlier. Remember, in the duality approach that we saw earlier, we could negate a formula that contained conjunction, disjunction, negation, true and false. We did not have implication, biconditionals, etc. That restriction is still going to be with us. Now, when we negated the formula with conjunction, disjunction, and negation, what we basically did was we converted and to or to and we replaced p by not p, etc. We're going to do the same thing for universal and existential quantifier as well. So we are going to change and to or to and, etc. Additionally, we are going to change for all to there exists and there exists to for all. So for example, if I have the formula that is given here, it's for all x. Now I have px and not of qx or rx. The negation of this is going to be, I am replacing for all with there exists. I'm replacing px with not px, I'm replacing AND with OR, replacing not QX with QX, replacing OR with AND, and RX with not RX. And that will be the negation of this formula. Once again, we have reached the check before you go ahead slide. I want you to be aware of the relation between the universal quantifier and conjunction, as well as the existential quantifier and disjunction. Note that when the universe of discourse is finite, we can always replace a universal quantifier by conjunction and existential quantifier by disjunction. However, we do need these operators when the universe of discourse is infinite, because we can't write it with respect to the conjunction or and disjunction or, because in that case the size of our formula will be infinite, and that is one thing that we are not allowed to do. We also looked into how to negate a formula containing for all and there exists. Note that this was similar to the duality idea that we used earlier, except that we need to do additional work, which is that we need to convert for all into there exists and there exists into for all. So I want you to be able to negate these sentences, and the answers are at the bottom of the slide, but I want you to check whether you get the answers that are same as what we have here. We have reached the end of the module. I want you to do the review quiz for this, as well as identify any questions that you may have come across while reviewing this.